So the first question is, I've just earned my PhD in statistics and have worked as a data scientist for 2 years. There are plenty of tech jobs, but I'd like to work in environmental science or green energy. How can I find jobs in environmental science? First of all, I will confirm your suspicions. Yeah, there's a ton of tech jobs out there. Oh, sorry, I'm looking at the wrong thing. There are a ton of tech jobs out there, and obviously solidarity for wanting to stay in science. Obviously, I don't work in environmental science, so my knowledge on this is incomplete. But we actually have a previous video with Elizabeth Manshart, who she talked about, for example, if you're interested in government jobs like the EPA, you can actually go and set up a little tracker where it'll ping you every time that the EPA has a job or the government has a job in a specific topic like data scientist or statistician. And so if you check back with me, if you come back to this live stream video, just give me a day or so, I'll find that that video in that location. And Elizabeth basically says, here's how you set things up. In addition to government jobs, there's obviously other options. You can do academic labs, although since you have a PhD, I'm sure that you are aware of the academic options out there. Then I would just assume looking for industry. However, there are plenty of industry jobs out there. You might actually be surprised about who is interested in having environmental questions answered. So you might want to consider things like mHealth or pharmaceutical industries, because those different places, even though they might not be explicitly for, they might not be, the entirety of their company might not be geared around environmental science. You can still, they'll still have jobs in those things. For example, if they're trying to look at, second order effects and things like that. So definitely you can open that up. Next question. Oh my, yeah. Okay, the next question is, how do you show off statistical knowledge when job hunting? I have a master's in statistics, so I know a lot of statistics concepts, but not much about data science or deep learning. This is also a super solid question. And just one thing real quickly, I don't think that any statisticians need to be apologetic about not being data sciencey enough, or I've seen a number of people saying, oh, I don't know enough about deep learning, which is, obviously just one tool in the tool chest. That's not going to stop you from getting a job unless you want it in a specific area, like some very specific applications. But I too like to show off insights on the value gained by using probabilistic reasoning. So I think that when you're looking at a data science job and you're a statistician, you can definitely show off and say, here are the ways that, taking specifically a probabilistic approach is beneficial. And one thing you can do is, a lot of probabilistic models that you'll use, a lot of predictive models will have a non-probabilistic equivalent model. So just a supertoy example would be, and this is identical, take linear regression. There's obviously, you can maximize the likelihood of a linear regression model. A linear regression is a statistical model, but it's also a least squares model. And so whether or not you're essentially using something like a model that focuses on a likelihood or a posterior distribution versus a loss function, if you go back and plot that data and show what the data is with respect to a probabilistic model, you can say, well, here's the added benefit. And data science jobs also, they gain a lot from statistical knowledge. One of my previous jobs in data science, I actually, my skill set was perfectly aligned with what they wanted. I had a large amount of experience working on that type of data, on the type of models they wanted. But what they ended using me for easily half my time was my just general statistical knowledge to help them plan out, strategize, do experiments and things like that. So they had a greater skill set than just what they needed for someone with a data science skill set of the modeling, the data acquisition, and things like that. So don't apologize for being a statistician. There's a lot that you can add via your form of probabilistic reasoning. And if you would like an explicit example of really highlighting the probabilistic approaches to what you do, I will pop that in the description. Again, just give me like a day or so to find the correct video, but it's actually one of the first videos in my channel. I think it's probably like the second one on Gaussian processes for machine learning. And there's a section in there where I explicitly say, we could just be using these things predictively, but these are probabilistic models. And that probabilistic element is added insight that's useful for data science and machine learning. I'd also just say generally for people who are interested in these fields, don't dismiss something just because it's called data science or machine learning or statistics and think that, oh, this doesn't have anything to do with me, or AI. Obviously there's a buzzword element, but there are also very competent people using any given one of those buzzwords, and it isn't a buzzword to them. They're just using it competently. So I would strongly suggest that people don't dismiss offhand a speaker or someone like that simply because they're using your unpreferred buzzword. Cool. And now, seems a shame to not answer the questions that people have right up here. So I'll hop back and forth between these. And if you give me 1 second, I'm just gonna try to adjust this so I have a little bit more desk space. And just as a note for people, I am trying to, my goal is as I'm better at these, we'll start making these a bit more frequent. Because obviously, people have pop-up questions, and I do like to have that live interaction. So, okay, next question. This is from Joseph. I have an MSc degree in mathematics with no experience. I've been applying for data science statistician jobs and haven't had any luck. Are there any good places to look for these jobs? Yes. So here's something. Trying to figure out exactly how I want to put this. There's been a lot of hype around the job opportunities in data science. And while it is true that someone with data science skills will eventually be able to get a job, I think that one of the things that's been misrepresented is they say, oh, there's this like 20 trillion data scientist shortage in the job market, and therefore you're going to be a shoo-in for getting a data science job. And I don't think that's true. I think it's more like saying part of the reason there's that shortage is because companies aren't putting people in those jobs. And so I think that a more accurate way to say is, if you're looking for a job in data science and you have the requisite skill set, it's not that you're going to get a shoo-in for like the first job, but your long run probability, your long run chance of success nears 1. And so I think that's the way that you have to look at it, that no matter how skilled you are, you're still going to have to play that numbers game. You're going to have to apply a lot, go out there. What I would strongly suggest is, 1, go, since you're a recent graduate, I assume you're a recent graduate, go to your university's career department and just straight up ask them, like, how should I brush up my CV for these things? They're there, they're paid to help you out. You paid your tuition. They're there to help you. Get your CV brushed up and get their advice on the best way to represent yourself. They can give you hours of time compared to my short answer. And the other thing is just play that numbers game. If you see some that are specifically related to your interests or some experience, I know you say you don't have any experience, but I bet you do have some experience doing something. If you have an MSc, you have experience in whatever your thesis topic was, for example. And if you see one that you're specifically aligned with, whereas what they need is essentially what you have, tailor your application to them. But for the other ones, I would really suggest playing the numbers game, because obviously you have a limited amount of time in any given day, and the job search is fairly random. So I would just say play the numbers game. Oh, this is a good question. It's hard for, sorry, I'm trying to read questions top to bottom, and while also seeing if anyone's commenting or replying. But so we have this JC Rollman. How important is maintaining a personal project GitHub? What types of projects should be showcased? That is an excellent question, because it actually relates to another one that someone earlier sent in, where what he was asking was, how do I showcase myself? Should I have like a should I do a side project to show people that I'm ready? And I say absolutely. You need proof of concept that you are good at what you do. Because if you think about it, think about what the salary of a data scientist is. then consider that your manager is probably making more than you, and you're going to be interviewed, for example, by people making about the same amount as you. A lot of money goes into just hiring a data scientist. And then even more goes in while they try to get you up to speed over the course of months, or maybe even, up to a year, getting you up to speed on what their company needs. And so that's a massive expense before you're actually delivering value. And so when you do things like a GitHub, or honestly just a website where you explicitly show what you do, some cool results and things like that, one, it shows gumption. Two, it shows that you know how to actually present your work to the people who care. So I think that the GitHub specific projects and things like that are extremely useful. If I need to go into more specifics on that, make it visual, make it maybe light on description, but if you can maximize the amount of visual content that's in there and make it intuitive, if people can intuit what you're doing, they will really appreciate you for it. And so that's also a good sign that you'd be a good person to work with, because you know how to display information in the way that they need it. So I would strongly suggest, whether it's via GitHub, on a personal website, whatever it is, have something out there as sort of a representation of your work. And actually, it reminds me, a few years ago when the company I was with was trying to hire someone, we had this guy who had this like awesome website and GitHub page and interactive like our Shiny apps on what he did. And like, we couldn't get the guy, like we super wanted him, but there's just too much competition for him, because when you can see what he's able to do, everyone wants him, because you know that there's the proof of quality in that. So it's a proof of quality thing. Or should I just apply to a PhD program? Okay, the value of PhDs. So that is something. And I'll just give you, PhDs take 3 to 5 years. And I want people to take this opportunity seriously. But so I'm going to sort of just say something that's a bit aggressive, but I think it's very important. The value of a PhD is nothing if you squander it. The purpose of a PhD is to turn you into an independent researcher, someone who can take a problem, a data set, an unspecified problem, or maybe they have a problem and they aren't given the data, and work towards solving whatever sort of nebulously defined problem is, turn it into a concretely defined problem and work towards it. But the main point of that is that you're skilled enough and independent enough to work as an independent researcher. And obviously for doctorate, to help you do that, you effectively become an apprentice to one or more experts, worldwide experts to do that. Those are your supervisors, and effectively you get your PhD from your supervisor. And so I would just say that a PhD is not an end all to your problem if you don't use it to the maximal ability. And I do know there's some extremely talented MSc people who I know personally. Like, I'm not just saying that and waving my hand. Like, there are some MSc statisticians and data scientists, like I could list off their names, who are easily as qualified. No, that's not true. They are vastly more qualified than most graduating people with doctorates. But the reason is because they're very effective independent researchers. So I would just say for that, it's always something that's interesting. I love the academic research, but at the same time, I would not say that it's strictly necessary, especially if there's also nothing wrong with you working some, getting a job, and then figuring out what you want to do your doctorate in. And people who do that are extremely successful because they have worked more on that issue of being an independent researcher. Cool, audio is great. Thank you, Maggie. This is okay, great. Also, just so you know, I think that we're probably on about a 5 to 10 second lag. What publications, websites, blogs, conferences, and/or books do you read, attend that are helpful to your work and would be helpful to current students studying? All right, Courtney. Obviously I'm a little bit biased in that because I actually, for those who don't know, I do a podcast on critical reasoning in data science. So it's scientific reasoning, critical reasoning, particularly for someone like me who is fixated on data. There are a number of places that you can go for. Oh, sorry, I need to not get distracted by that. There are a number of places that you can go. Publication-wise, we're actually trying to make some strides in this. So one, you can go to archive and find brilliant work. And I'm not saying brilliant in some loose way, as in you can find excellent work there. Do not be afraid if the publication you're looking for is on archive. Look at the people who wrote it. If they seem credible, consider it. The Journal of Data Science, I've actually, and this is a little bit of a biased plug, but I've actually been, joined the editorial board at the Journal of Data Science, JDS. That was at the beginning of this year. And one of the things that we're doing is we're creating a new section specifically called the Philosophy of Data Science. And what we're doing is these are non-technical papers that deal with the critical reasoning aspects. So what we're trying to build out are giving people access to more of that conversational, critical thinking, behind the scenes approach from world leading experts. So these aren't going to be fluffy pieces. They aren't going to be, just interviews of how I did this. It's essentially, data scientists doing a post-mortem on their work and giving you useful information about how they made certain decisions and things like that. And we're letting them vary. And so if you want a quick example of that, Courtney, you can actually go to Journal of Data Science. Lily Wong wrote the inaugural piece, for example, and what she did was she compared different types of COVID modeling. So for example, the more mathematical and mechanistic models like the SIR model for COVID modeling versus the machine learning and phenomenological models of COVID, and compared the different challenges and strengths of the different models, for example, how robust they would be in the event that the system changes and things like that. So I think that those are very useful. Other things really quickly, who else is good? Honestly, here's one good way. Go to an academic statistician's professional webpage, like their, go to Cynthia Rune's webpage, you'll learn something. Go to the Cambridge Engineering Department's machine learning page, and you're gonna learn something. That's actually a good point. One place that you might find that's very useful is if you look at doctoral theses are published and master's theses are published. And so usually some of the first chapters of those are usually introductory, where they introduce the methods and things like that. And the reason I find those very useful is because they're written by somebody who's recently learned it. And so I think that they're usually a bit better at helping you do the building blocks. So like if you want to learn about Gaussian processes, which are very common statistical model, popular machine learning, data science statistics, go to David Duvenode's, that's David Duvenode, Duvenaud. Go to his Cambridge doctoral thesis, and you'll get an excellent introduction to it. And so I think that's one thing that people can look at, where if you read people's doctoral theses and read the method sections, you can typically get a better description than what might be available elsewhere. But it is very fortunate that we are getting better about putting online the best resources that we can have available. I hope that answers your question. Other than that, I'd also say, honestly, I'll just plug my podcast. We're doing our best to make sure that people can have conversations and learn from people. And I think the value of those is you just listen to them, and it's like layers of paint, and you hear about their concerns and you start getting the connection. So even if someone seems a bit more advanced than what you'd like, or they're talking about an application that you don't care about as much, just go listen to them. You can put the video on 2x speed and get through it twice as fast. And just listen to those things, and you'll start making those connections. Oh, okay, this is cool. Do you know people who have worked on fine arts related data science projects, like image analysis or object recognition and painting related to the fine arts and museums? I do not. A lot of that stuff looks super cool or terrifying and trippy. Honestly, I keep thinking that at some point I would like to just create a GAN and just train it on a whole bunch of video game and coding music to help me focus, and then have original coding music. But I don't actually know personally any people like that. I do though know that I do know a lot of people who are in, for example, medical imaging, but no, I don't know too many people specifically working in that. But I've seen a lot of cool stuff, but my knowledge on that is nothing more than sort of the casual reader towards data science or some of those more technical things. But it does look cool. But yeah, if you had any more specifics like about like how you get into that, I wouldn't quite know, but feel free to pop another question below, and I'll see if maybe I can get you the advice that you're looking for. Do you have any advice for someone recently accepted to a statistics program? My bachelor's degree is in economics, and I have no programming experience. Well, that was me. My bachelor's degrees are actually in math and economics as well. Then I went and got a master's degree in operations research and then another one in statistics before doing my doctorate, and I worked some in between there. What are my recommendations for someone just starting a master's in statistics? Well, I'm going to go out and make an assumption that the reason you want to do have a job in statistics because you want to analyze data of some sort. And I'd strongly suggest that, given that you said you had no experience, which is perfectly typical for a lot of people, as soon I'll just give you the blunt information. You're associated with the university. Go out and get practice analyzing data. Don't wait until you've learned all of your math stats and things like that to start analyzing data. Just go out and get your feet wet. The reason for that is because most people do not learn best, I think, in classroom settings. They learn in applied settings. And so the work that you're learning, the topics that you're learning in your class will stick better if you're directly applying them to a problem you care about. And so you can leverage the advantage of being in a university because essentially you have a large number of departments. Many of them have data and they need someone to analyze it. And they might have having a willing and eager master's degree student is better than not having someone analyze it at all. So I've given this advice to a lot of people before, but if you're in a master's degree, you're in an ideal place where you can literally just throw yourself at some data. If you mess up, just dust yourself off and keep trying again. And you can do it in any department, like basically any scientific department doesn't have someone looking for someone to analyze their data. I don't have any experience programming. You need to correct that. Just so you know, programming is at this point essential for even the most simple things like data manipulation. And so, for example, say you're in an economics, in your economics program, you might have had some like point and click software and things like that. But that in reality, that isn't point and click softwares. I don't think are sufficient to handle the complexity of data that's going to be asked of you immediately. So it's a very low threshold. Very quickly, if you're looking for someone who can teach you those things, I always just recommend Jose Portilla. He's on Udemy, and you can get the like Python programming or R programming. I would suggest either of those two because essentially they are open source software, or so they're open source programming languages. And I think that you can make rapid progress with either of those. So the best advice I can give you is start analyzing data as soon as possible. That will give you an appreciation for the actual classes, the mathematics and things like that, and to learn to program because you're going to just need that anyway. It's going to give you access to so much. So I'd be misleading you if I didn't give you that information. Okay. So the next, oh wow, okay. What tutorials do you recommend for creating and training models to hone your skills in supervised versus unsupervised learning? Okay, yeah, that's a good question. I'm a big fan of Jose Portilla. So again, just because one of the advantages, the reason that I keep harping on things like Udemy is that they're inexpensive. And so effectively you can buy a course. Don't buy them when they're charging $200. They go on sale like every third day. And just you can buy a course for $12 and you can listen through it once. They usually have coding practices. They're extremely good teachers. And so I think that in that case, it's a very good product out there. It's inexpensive and you don't need to invest massive amounts of time. You can effectively be knocking out a lot of basic skills that'll help you appreciate your coursework more. Ways to do it. So what would I recommend? I mean, I think some of those, like if your baseline is 0 and you haven't used any statistical models, first of all, I suggest that you get more comfortable with things like data exploration and plotting and things like that. And the reason is my goal isn't to slow you down. I know it's frustrating when you're eager to get into something new, and it sounds like people are trying to slow you down. But I just asked yourself this, like, are you going to be alive next year? If so, your question then shouldn't be, what should I do, for example, today that will make me the most impressive data scientist tomorrow? But it should be, what will make me the more impressive and competent data scientist next year? And I think that a lot of these things are, the better you can understand your data and things like that. Definitely, if you're starting from ground zero, learn data exploration, learn the coding that you need to plot your data. That will actually help you generate a lot of the hypotheses that you would then want to base your machine learning models around. Other than that, honestly, I wouldn't suggest courses. Like if so, say you do know some of these models and methods, and you're ready to just really get into it. I would not suggest courses. I would honestly suggest that either if you are currently working in a job, find some data that you care about in that job. And the benefit of that is twofold. One, you'll care about it more, so you'll be better at it. Actually, it's probably threefold. Two, you'll have a subject matter understanding of it that's greater than if you're coming into something cold. And three, it complements your job. So essentially, what you don't want is someone saying like, well, if you're going to be working out of hours for an extra like a few hours a day, why not have that benefit your job? You can bring that to your boss and things like that. So working on data that you already have available for your current job is a good way to do that. And you can bring your boss that something extra, and they'll appreciate it. So I think that builds much more of a virtuous cycle than saying, oh, I'm going to force myself to use this other publicly available data set that I care less about. However, if you find that you do care way more about that publicly available data set, do that, because whatever keeps your attention is best. I have a question about how to balance using Python and R programming in order to get a position in data science. Okay. I'm not sure if there's a follow-up sentence to that. Oh, and you're welcome. So I guess the question might there be like, do you use R? Do you use Python? What do you use? First of all, I think I'm glad that you've narrowed it down to the probably two best choices. Alternatively, you might consider Julia, depending on your computational needs. But if you're in the learning process, both are good. I have used both. I've coded in both on a daily basis for a number of years at separate points in time. So previous to my doctorate, I was coding on a daily basis in R. Subsequent to my doctorate, I code on a daily basis in Python. And the main difference there is that I was in more of a research setting beforehand. So I was working in a lab, a hospital lab. And so one, I was more comfortable with R, and there wasn't as much need, for example, for me to plug my my data science, my models, and things like that into another system. So if one of the main benefits I found with Python is that it's much easier. For example, if you're dealing with software engineers and people like that, you can essentially package and hand more stuff off to them. Although at this point, I don't know, I'm sure R has made excellent progress towards those things anyway. But in general, I found that Python is very useful if you're going into some more of the techie industry. If you're in research, for example, for those who have seen my other Q&As with Richard Franzese, I'm pretty sure he is a daily R user. And there are benefits to R. Like I find that I can typically code and do analysis faster in R. I get bogged down by fewer like data errors and things like that. So I think R can help you go faster. And it's great if you're in that research setting and don't need to deploy. I'm sure that R has the required skills that if you need something more advanced, it can do that too. Like obviously, I'm not going to throw rocks at Hadley Wickham or any of those people who are doing excellent work. I'm just not as familiar with that upper level of R because I've been out of that for a number of years. But you can't go wrong with either. But I would just say Python works for either. I do find R a bit faster, as in me physically coding it, not computational comparisons, but I find that a bit faster. So I like that advantage, but I also like the advantage in Python that I'm typically able just to hand it off to a software engineer. So if you're going to end up working with software engineers, I would suggest Python. And balance-wise, honestly, I would suggest digging in, figure out which one would be good, dig in and learn that as well as possible. Then you can transfer over. So I think you should learn deeply on that one. I'm going to take a quick sip of water. Okay. A follow-up from Joseph is I've gone to a university with help on my CV recently and it should be good. Yeah, so definitely do that. Those are the professionals, they keep up with it on a day-to-day basis. Obviously, I'm not applying for jobs on like a frequent basis, so their information is much more up-to-date than mine. Oh, cool. So Enrique Sanchez, how would you try and get experience in Agile data science when you're not in a job that uses Agile data science? So for those who are not familiar, and I'd welcome the comment section if they would prefer a different definition of Agile, but Agile is a development paradigm. So a paradigm by which people typically develop software. And I think there's a big, I don't mean to stand here gaping, but I'm trying to, the worst thing you can do is, say something wrong on the internet or make a mistake. So I'm just trying to get the right information out. And I'm a bit conflicted about this because the fact is, I think people are still trying to work out how to best essentially manage and organize data scientists. And while there are certain companies like FANG, the Facebooks, Apple, Amazon, Netflix, Google, who have enough of a structure and there's enough sort of value generated from data scientists that they can really get the structure correct. A lot of other companies, because they have a smaller data science team and it's a bit more peripheral and things like that, and it's not directly related to them immediately adding value, by which I mean generating the amount of money that allows for your salary. That's still a big open question, and I'm not really sure what the best answer is. I'm not even sure that a software type approach to data science is the best idea. There are differences. There's exploratory elements, there's research elements and things like that. So I think trying to fit a data scientist into a software engineer's production scheme might be ill-advised. At the same time, I don't think it can be totally loosey-goosey and just completely untethered, because the fact is data science jobs and tasks can have mission creep and a lot of things where you'll burn up a lot of resources and not develop value. But no, it is I'm not so sure about that. Like it's basically, to me, unless I'm wrong, I'm just gonna see if anyone's correcting me or has something to contribute on that issue. But no, I'm completely open to being corrected on this, but I don't think that I don't think that making a data scientist operate like a software engineer is a data science job. Then effectively what you're wanting is a data savvy software engineer. And so I think that there's probably something in between sort of that software engineer where you are very goal oriented and task oriented, while still accommodating for the fact that you have this inductive research process that's part and parcel to a lot of scientists. I would also very quickly point out that just to paint broadly, software engineering is a deductive mental process. Data science is largely based on both inductive, abductive, and deductive processes. So there's a lot more going on there. There's a lot more training. I'm not saying that software engineers don't know that stuff, because obviously software engineers are the people who built the platforms on which data scientists do so much of the work and are the reason we have high salaries. But there are different modes of thinking, and I think that those run separate. And I don't know enough about Agile to know if that is actually, if one of those can accommodate the other. But yeah, no, everyone, data scientists should love software engineers. They're great. They are the reason why we get paid so much. But I'm not sure about the management strategy and trying to apply a software engineer's management strategy to a data scientist. But maybe some super smart people will come up with a good way to do it, or a good middle ground. Do you have suggestions for someone pursuing a PhD in applied statistics to be a successful candidate for industry, i.e. not squandering the PhD as you mentioned? Well, thank you, Maggie. I appreciate, you got the not squandering thing. So yeah, I appreciate that, that you really listened and took that one to heart. Do you have suggestions for someone pursuing a PhD in applied statistics to be a successful candidate for industry? There are certain things that you can do. And honestly, I don't think it's, I think that if you do a good job, if you prep yourself such that you could get a job in academia, there is a place in industry for you. And that's just, again, a numbers game. Where if you do the things that would make your supervisor, so say you're going in to an American PhD program, and then actually someone asked me about the UK PhD thing in a bit to just remind me in the comments, so I hit on that and don't forget. But if you go into an American PhD program and you do, say, for example, your 2 years of coursework, and then you start your research, and if you work hard enough and are successful enough that your supervisor would hire you as a postdoc or suggest you to another lab, you've done enough of what you need to get a job in industry. So I don't think that these things are orthogonal. You just really need to show that you demonstrate good work. And obviously publications help, but developing as an independent researcher such that you can steer your own path, create your own publications. You don't need someone holding your hand to come up with a research idea and things like that. And actually, one thing I'll address is that a lot of people are worried that they don't have, for example, like the creativity or the knowledge a priori before starting this doctoral process to do all those things. That's fine. Don't feel bad about that. The point is to develop it in that process. That's why we have these. If people were all good, naturally good independent scientific researchers without any help, will there be 9 billion independent scientific researchers walking around? But there aren't. It does take a process and work. So essentially, if you really work to make sure that your supervisor's happy, you're publishing, those are good things. Another thing, though, is actually, I will just warn you, since I can say this, not all supervisors are going to get you into that position. I was talking to a very successful statistician who pretty much everyone knows. And his interview's coming out in a week or two. And one of the things he said was, my goal is not to use my graduate students as basically just worker bees. My goal is to essentially let them become the scientists that they can be. And I think that's important. And the fact is, people notice that. And some supervisors will get a reputation if they only use their grad students and their postdocs as worker bees. They will get that reputation. You can be on the lookout for that. I was very fortunate. My supervisors essentially gave me the right level of they really kept an eye on me for the first several months of my doctoral thesis work. And then once I demonstrated that I was good independently, they just checked in and helped me sort of correct my trajectory, give me other ideas, give me support, introduce me when they saw that I was successful. They started introducing me to other researchers who I could help and things like that. So, but what they didn't do is say, well, I have this research problem, Glenn, you go do this research problem and do it this way and test my idea. So I would say that work to be independent, test out your own ideas, and there will be points where and Maggie, just so you know, this is the question I'm still answering. There will be points at which perhaps your supervisor might say, well, I really want you to do something this way. And I've had examples of this where my supervisor really wanted me to do something in one way, and since I've been working on the problem, thought, no, that I don't think that's going to work. I think this other way is going to be better. And it turned out to be, I was correct. However, what I didn't do was ignore what he told me to do. What I did was I worked double hard and I did both and kept moving along that way. And I'd say there's nothing that beats somebody who's willing to work hard and get those things done. So, and I know that there's a lot of social aspects to doctors and things like that. But yeah, you can, if you work hard and are productive and do the things that would make your supervisor want to hire you at the end, you'll be amply good for industry. If you happen to tack on an industry, summer project or something like that, all the better. But you might not want to do those if you're really making massive progress on your thesis and doing great scientific work there. You might just want to focus on that. So yeah, I would say that those are the ways to do it. And that's a very interesting question. And honestly, if I can just take a quick detour, those are the types of questions that I was hoping that sort of these types of Q&As would be. And once I can figure out the tech better, or I can actually have a guest or something there, it would be really great to start having doctoral students on. And we just talk through what their sort of like their research questions are and some of the ideas that they're trying to vet. Because I think that's the bit that when I was at Oxford, that was the part that I enjoyed the most. It was conversing with other postdocs, with other doctoral students, conversing with postdocs, master students, and the like, and really just enjoying that vibrancy of thought and going through different ideas, because there's a massive creative process to data science and academic research. That's it's something not to miss. So yeah, Maggie, if you when you get farther along or you have another question, it'd be great to have more of these types of conversations on specifics, because I hope that is helpful. Take a quick sip. Okay, yep, this is a good one. Charles B, will you give some insight into the roles, responsibilities, education? Oh, sorry, I just actually realized I need to plug in my laptop. So if you'll just give me half a second. And the line is not large enough. Okay. Sorry, if you guys just give me 1 second. I just realized that, so I'm using a separate laptop here. So just give me 1 second. Oh, yep, and I see a SQL question has come up. That was bound to happen. Cool, let me see, is that close enough? If you'll excuse me just 1 second, just to see how far I can lengthen my cable, and I'll be right back. All right, I'm still here. All right, cool. Our live stream will not now instantaneously die on us. All right, so the question was, can you give some insight onto the roles, responsibilities, education, et cetera, for data analyst, data scientist? I assume that's data architect and data engineer. These are good, and I would add to these probably machine learning engineer and statistician while we're at it, because obviously given the crowd. And so how should we begin this one? I think that the data analyst role is probably the again, people don't like definitions, and the fact is anyone can name a job anything, and also companies tend not to be very good at writing the job descriptions for a lot of these things. But I would just say this, data analysts, for example, they tend to have, the data tend to be more curated. It's typically a bit more of a beginner's position. And so you can essentially become a good data analyst, and you essentially are being like fed the data and you can look at it. And sort of, I would say like the upgraded data analyst, and I've never been a data analyst, so this is just my basic understanding, is that perhaps they might also do a lot more with, for example, like SQL and a lot of that, more of that data acquisition bits. So essentially they can acquire data, but they aren't doing things typically like modeling, prediction, and things like that. So essentially you're using the human to interpret the data. The data scientist, so again, this is sort of the difference between maybe a data scientist and a statistician. And no one's going to like these definitions because obviously there's always exceptions. But the main difference is, because I've worked as both, I would say it's attention to things like data acquisition and data and deployment of models and deployment of work product and things like that. So effectively, never as a statistician have I actually had to deploy one of my statistical or predictive or probabilistic models. It's usually like I fit my model and I could feed the results back to somebody who will then interpret it and use it. So that bit wasn't automated. Whereas for the data science jobs, eventually the human comes out of the loop and your data science model or predictive task sort of has to stand on its own. And that involves a lot of, extra curation and making sure that your data has you have stable access to your data and the data is high quality and things like that. Data engineer, sorry, I'm trying to find, I need to start highlighting these questions. Oh, sorry, I lost you. The data engineer, I have not ever worked as a data architect or data engineer, but I think a lot of these issues are essentially getting reliable access or pipelines to data. So actually in my own job, I work extensively with a database manager, and he's essentially my lifeline, where for a lot of these more technical database questions, like I can learn, I know plenty of databases. I know far more now as a data scientist than I learned before. But the fact is there are certain fundamental aspects like ACID and things like that, where you totally don't have to think about those in research settings. But as a data scientist, you do. And but if it's beyond that, I do work with a database manager who really holds my hand and helps me with the things like data security, making sure that I don't essentially blow up the system and stuff like that. So talking to project managers who essentially make sure that the data is what we believe it is and things like that. So I'm not as familiar with the data engineer, but those are mainly people developing the pipelines to have access to data. So they're essential because when you have a huge volume of data, you need people doing that. And I would just say maybe a machine learning algorithms engineer. Machine learning, you're pretty much developing predictive models. But the idea is at some point, computation becomes an issue, the computation of data. And that's where some of the more engineering definitions come about, at least to my understanding. Although I've never worked in those roles, but I've been appreciative of them. They say data science won't be around later. Does that just mean that the skills required in data science would be absorbed into a new job title, i.e. AI engineer? Obviously, I don't know who they are. I could definitely see the ways that data scientists will stop being a job title. They just move on to a different buzzword. I think that's definitely, Socratic trouble. Good. If it moves on from being a buzzword, I think you'd start seeing those disappear. I think that there's a lot of people who think that they want a data scientist on board, but they actually don't. They either want a data savvy software engineer, or they just want a statistician, or maybe they do want a data scientist, but they don't actually know what to do with a data scientist once you have one. There's a lot of things like that. So I could definitely, I could see the title disappearing. I don't think the skill set is going to disappear in any time in the foreseeable future. But you might the skill set, for example, might be, imagine when they're had the initial automation of cars, and not automatic cars, but as in they were trying to get assembly lines for cars. And there might be a reshuffling of how we sort of silo different things. So imagine that we get way better at the data engineering process. And because of that, then data scientists won't need as many of those data engineering skills, or they're more baked into the cake, or the tool set is there. So I think a lot of these libraries and tool sets, they might actually help data scientists circumvent some of those more data engineering tasks that you might need to do, or might be less burdensome and things like that. So the skill sets could definitely be reshuffled as people find efficiencies in different subdomains of data sciences. But the skill sets are still going to be there because, we haven't invented, artificial general intelligence yet, and so we're going to need people to be working on those things. But no, it's definitely a good question to be asking. It's which of these skill sets are sort of incidental to the current situation, which is typically data scientists being applied to software generated data and things like that, and which of these are more fundamental skills that will sort of persist over time. So it's a good question. But I think that's probably the way it will go. This is analytics, for example. Analytics was a buzzword before this. And I don't see, I guess you have analysts, but data analysts, but advanced analytics and things like that, you see those job titles less frequently, but they're hiring the exact same people as those with data science credentials. How important is cloud computing, and which cloud service do you recommend learning first in today's demand? Any recommendation where to begin learning? Unfortunately, Jose doesn't teach cloud yet. Oh, sweet. Yeah. So Credential, you do your homework. Yeah, so AWS tends to be the way to go. As in, so there's several things here. One, once you have a job, you're just going to end up doing whatever your company works with. So, and that's pretty much going to be out of your control. You know that they already probably have something in place, whether that they're going to be using Azure or AWS, or maybe they'll really have some like Databricks or something like that, which then also feeds into those other things. Or maybe they'll still be, you know, storing things on their local computers and just waiting for that next ransomware attack to hit them. In which case, you know, obviously start looking so you can find your next job. But the main thing there is that is going to be handed down to you from on high. And I don't think there's any way to avoid that. At the same time, AWS, if you had to choose one, I'd choose that one because effectively it's used for software. It basically has everything. Jeff Bezos won that round. And so effectively, a lot of people are using it for software engineering. So if you have to be working, if you're a data scientist who's working with a software engineering team, that's going to be there. And you're going to have to probably integrate with AWS. If you want to be putting your data science on the cloud, especially if your company is storing their data on AWS, then yeah, you're going to have to use AWS. And whereas, say, even like 2 years ago, AWS has had something of a probably well-deserved reputation for not being well documented and being sort of opaque in a lot of things, but they've gotten a lot better. They have immense, I won't call them libraries, but services and offerings that make things easy. And so you don't need to learn all of AWS. You can learn little bits and little chunks. If you do want to learn AWS, pretty much just go to their website, and they are more than happy to teach you how to become a customer of theirs. But you can also find those on Udemy. And so actually, one thing is, if you are on Udemy, I think there are actually a few free courses on AWS where they just give you a high-level exploration of everything that's in AWS. So if you want to know what the difference between S3 versus EC2 is, or what Lambda is, or all those things, they have them there. And you can, I would strongly suggest if you're going to do something like AWS, get that high-level overview, and then work from there on something specific. Yeah, I hope that answers your question. And I thought that Jose actually had a course on that. Maybe just keep scrolling, but otherwise, if you type in AWS, you can find even free courses that give you that overview. But again, just go to their website and you can actually get the course, see the courses, get the instruction and things like that. I mean, it's such a massive product that they're always happy to train more people on how to give them money. So I think that's the way to view it. Hi, what Python course would you recommend on Udemy? I honestly, I recommend, so I've mentioned the Jose Portilla course several times. And actually, maybe just a quick thing. This is a little bit mercenary, but if you can click the like button, please feel free to click that like button. What it'll do is we'll make sure that more people will be able to see this interview, and the channel can grow some, and we can do more of those. So if you guys don't mind, just like pop in and click on the like button. Oh, sweet. Yep, it's going up. Great. Yeah, that'd be really appreciated. And also just consider looking at other things on the channel. I try to make things of high value to everyone. But yeah, so now the Python course I'd strongly suggest Jose Portilla has multiple courses, and the way to look at it is he's taught like millions of students. And so what I'd suggest you do is look at, I believe he has like a machine learning bootcamp course. He has like a plotting and visualization with Python. He has a large number of courses. And what you should really do is actually, you can click into the course and you can look at the curriculum. And what you'll see is that there is a fair amount of overlap, because essentially he takes the essential Python chunk and he just puts it in each of his courses. His Python like Zero to Hero course. It's much longer and it is more for like the computational aspects of it. But it's also very good. Again, like these are good courses and he's charging $12 to $15 for them at this point. And that's having accounted for the inflation and things like that. So you can't go wrong. But what I'd suggest is, I think the machine learning bootcamp one probably is very good, and it covers most of the stuff. So yeah, if you go there, then you can just scroll through his courses, right click, create a tab for the different ones that look of interest, and then just compare the syllabuses, and that's where you can go. But I think the machine learning ones are very good, and he has things like time series and stuff like that too. Okay, so I'm just trying to find my spot in the next one. Cloud computing, Python, thank you. You're welcome, Wenxiao. Try to look for recruiters on LinkedIn. I've had people contact me out of the blue because of my prerequisites. I've been posting on LinkedIn. Yes. So this is something. So I actually had some people do an experiment where I had some of the other people who went to like elite engineering and statistics programs. And I was just talking to them because I noticed that there's this big difference between essentially all of the master's degree and bachelor's degree people who are looking for jobs, and they're having so much trouble and frankly not being treated well by recruiters and things like that, people being dismissive of them, not following up, things like that. And what they did, and versus how essentially people like the doctors are being treated, and if you're from elite university versus a lesser known university, things like that. And I was trying to figure out if there was a pattern in there. And yeah, I would say that there is an issue where if you go to an elite university and you have a PhD, you will have recruiters constantly pinging your inbox in LinkedIn. However, LinkedIn also does have that process where you can actually, they know where you're from because obviously they're tracking you and everything like that, and they're tracking across the internet. But you can set up a search so that get notifications for new data science jobs in your area and things like that. And the nice thing about LinkedIn is they sort of have this sort of common application, so you can do a quick apply, and that's a good way to play the numbers game. So I would definitely suggest LinkedIn. And so even either one, recruiters will contact you, just spend the hour getting your LinkedIn account all buffed up and looking nice and with all your skills and everything like that. Have that website, have that GitHub account, things like that. But yeah, have that and then be on the lookout because you can set a notification to get job updates in your area. I actually even use that, like, I'm not looking, but I use that because I like to understand what other companies are doing, who's hiring, things like that. And so it's a good way to keep track of an industry. I do the same thing for software engineering jobs because I'm just always curious about who's hiring where, because that can help you sort of form a broader understanding of what's going on in your world. Clarifying that with regard to prereqs, I listed a technical project with an API data analysis. I did and put it on an online course. Yep. Yeah, stuff like that is really cool. And I'll just double down on that. If you can do things, there's the data analysis side, but there's also like deployment and interaction and things like that. So if you are showing that things like you're working with APIs, it's showing that you have more of the technical chops to bury in with a technical team and things like that. So definitely, if you can have things like that show that you have more of those technical chops, it's massively beneficial. I see lots of questions around R and Python, but SQL is often forgotten. I did a degree in data analytics and didn't study SQL. Now I'm looking for work. I struggle because of all the positions that require it. So this is, I'm gonna take a sip because this is gonna be a long one. The SQL question. The SQL requirements of a data scientist or a statistician, I think, are very much like the question, how much math do you need to be a statistician or a data scientist? And I think it's an ill-defined question. One, just to actually help you out, because obviously that's what you need more than anything. There are courses you can learn SQL in a week, or a weekend. up to like a fairly respectable level. Again, you can go to Udemy and get a class, a $12 class on SQL. You can get one with Python and things like that. And the reason I bring those up is because, well, you don't need to go to college and pay a lot of money for some of these extra technical skills. And you can get those skills quickly. So I think that you should not, I would just view it this way. How much time do you spend on LinkedIn and searching around online for jobs? If you took one of those weekends and spent it learning the SQL skills that you need, which are available online, and you can get them very quickly. Like, I mean, you said you have a degree in data analytics, so you're capable of doing a technical degree. Getting the added SQL skills is not going to be a problem, and there's plenty of people out there willing to offer it. So honestly, I suggest you go dedicate a weekend. Just basically say, my week doesn't end this week. I now have 2 full days that I'm going to learn the SQL skills that I need. It's a little bit of a coin toss about which potential employers will actually, like, for example, quiz you on SQL. I think a lot of potential employers also overestimate the SQL skills that people need. So this gets back to the question about SQL skills being a poorly defined problem. And if you check back in this channel, I'm actually going to draw out sort of, I have a model of how much SQL people actually use. It's like how much math people use in data science. And I think that there's a conflation of 2 ideas. One, how often do people use SQL? And 2, how much of an expert in SQL do you need to be? And so I think this is an important issue. And if you think that's an important issue, don't forget to hit that like button. But or leave a comment. But yeah, on one issue, it's like, how often do you use SQL? The answer is like daily. I use SQL daily. How much of an expert do I need to be in SQL? How often am I using, for example, innovating or creating new SQL queries? Much less frequently. So the issue is that effectively a lot of data scientists, I think we use fairly basic SQL, but we just happen to use it on a daily basis. And so especially, for example, like when you're at the beginning of a project, that's when you're going to be using more, that's when essentially you're be using more of your SQL skills, because effectively you're busy searching out the problem and developing the queries from, for example, different databases, different tables that you need to get the data to do your analysis. So effectively, there's a period where you might have like intensely working on SQL and having to think in SQL on a usual basis. But at the same time, once you've worked out those problems, you're typically, at least in my jobs, I find that it's the most daily I'm used to using basic SQL, very basic SQL commands, self joins, things like that, where it's just, it's like a step or 2 above a select statement, but it isn't massively complicated. And so, yeah, I think there's an issue with that, which is maybe a lot of employers don't appreciate it, where they think that, oh, because you have to use SQL daily, you therefore must be an expert in SQL in order to do this job. And I say that's incorrect. I think that's something of a categorical error. And so I don't think that's true. I think there's a similar thing with mathematics. Although mathematics is different because mathematical thinking is indispensable to data science. However, that doesn't mean that you're always going to be, sitting down and doing analytical mathematics on a pen and paper all the time, but you will be thinking mathematically all the time. And so I think that's another one where people might think, oh, because I'm not using mathematics, pen and paper, solving an equation by hand, therefore I don't need mathematical skills in order to do data science. And I think that's incorrect. We just use them differently in more subtle ways. So yeah, I hope that answers your question. But the main thing is, go to Udemy, spend the weekend or 2 that you need picking up those skills, pop it on your CV, and march forward proudly. And the fact is, I think that most people in their actual SQL quizzes, first of all, a lot of companies that say they require SQL might not even quiz you on it in the job interview. And the ones that do, they might even just throw out a super tepid join question and call it a day. So don't let that dissuade you from applying to a job. Also, you can just make the point, well, I'm at it. You can also just make the point that you can learn those things. Like, it's not like you're only going to be at the job a week. You're going to be at the job for potentially years in your time. So you just invest, get those skill set. Okay, yeah, Maggie, definitely. It would be cool. So we've been having a few conversations. So it said it would be love to continue having the conversation as your PhD continues. Yeah, that's definitely cool. There's a few people who I think are interested in having these types of conversations. It would be great to have them online. Or sorry, just I think it'll make more people. If a few people can be brave and say, yeah, I'm going to come on and I'm going to answer these questions, and so we'll have that discussion, and they don't mind essentially. Showing what they're trying to learn and the fact that they don't have all the answers to begin with. I think that that's a great thing. And other people can start learning for it. And it'd be great to start having a community around that issue. So yeah, definitely keep in touch with the channel, and it'd be great as we have more of these. I've already started scheduling the next few Q&As, so I hope that's helpful. Cool. All right, those are the live ones, and I realize that we still have quite a few of the questions left, but why don't I answer one or two? Would people, maybe if you just tell me in the comment section, would you like me to keep going through and asking some of these questions that were sent to me in advance? Because I realize that some of you sent these questions to me in advance and you still might be waiting in the waiting room, or not in the waiting room, but waiting for me to answer the questions you sent in. So why don't I answer some of those before my voice completely wears out. Okay, so one person asked, I have a BS in math and statistics, and I'm completing my MSc in biostatistics while working. What's the difference between basically working in machine learning with a PhD versus without one? I think we've covered that one, but let me know if I haven't. Oh, here's an interesting thing. This is sort of a combined question that multiple people asked, but they say, I want to ask what would be the best time to apply for jobs as a PhD student. I'm interested in Biopharm and clinical trials. And so my general advice on this is whether you're a bachelor's degree student, a master's degree student, or in your doctorate, apply and do some summer jobs. Why not? Just go and do some summer jobs. I think that's helpful. It's the best way to solidify the information that you need. It's going to keep you interested in your technical work. The second thing I would say is this is something very common for people interested in Biopharm. If you're interested in Biopharm isn't the giant umbrella that it used to be. There are things like there's pharma, there's biotech, there's mHealth, there's digital health. You might be interested in life sciences. There's more general biology. There's medical statistics. There's clinical statistics. Those are different things. There's general healthcare problems. And so don't limit yourself to that one thing. So keep looking broadly. Don't limit yourself just to the word Biopharm because you think you want to do one thing. Keep looking broadly because all of those things are interesting and might be of interest to you. So you're just gonna have to ask yourself, would this be of interest to me? Okay, maybe this would be a good final question unless people have other follow-ups in the meantime. Cool, yeah, so I'll keep asking this, and anyone, if you get your questions in before I'm done answering this current question, then I'm happy to answer it as well. And again, if you're still on, don't forget to leave a like because it does help the channel. It's not for my ego, it's to basically tell the algorithm to show this to other people so that they can see it too and hopefully benefit some. Yep. I have a question pertaining to choosing a research topic. Honestly, I have no idea how to go about it. I feel like I don't feel creative enough to come up with anything. However, I'd specifically like to ask you to know how to work on or come up with ideas for collaborative research projects. For example, I've always been interested in biodiversity. Is this an acceptable type of research for graduate school, or is it preferable to be the only person working on it? So I think maybe you probably have, there's probably a few things to this question right here. One, actually, let me just say this. When you say, I don't feel creative enough to come up with anything, I would say that's perfectly fine for someone who's still early in the field. The creative process and things like that, it comes with experience. People think that creativity is just this like magical unicorn flying around and shooting out rainbows and things like that. There's also creativity that comes from someone who knows how to solve problems and realizing that there's second order problems caused by your initial attempt to solve the first order problem, things like that. So don't be worried until you've tried to work as an independent researcher. That's how you become creative at those things. So don't feel worried because it doesn't come a priori. Those things come with experience. And if you're working hard, that experience will come. Be worried if you've been working at it, for 2 or 3 years and you still don't have those creative ideas. That might tell you something, but until you've really been in the trenches solving some problems, that's when the creative process comes. It also helps just to work until 2 a.m. sometimes and let your brain start melt a little bit. That's when I have my best, most creative ideas, even though I'm utterly exhausted. The other bit that I noticed about this is, so the collaborative research project, is this acceptable for graduate school, or is it preferable to be the only person working on it? So I think a lot of graduate students get worried that their work isn't going to be novel enough or not independent enough to be of use. And to that, one, it's a good thing to worry about because obviously you want to keep the quality of your work high. At the same time, being and I've already said, it's important to be an independent researcher, but that doesn't mean that, you just have to be this one person. You collect all your data alone and you do the analysis alone and things like that. Obviously there's whole fields of research where, for example, if you're doing biodiversity, there's probably gonna be a field research component to it and things like that. So that will not sink your ship. There's a lot of areas that you can do. And just because someone else is collecting your data doesn't mean that you're not doing independent research. Obviously for my work, I was using patient hospital data. And the fact is, obviously those are picked up by machines. Those are attached by nurses and clinicians. Actually, I did collect some of my data for a side project, but for the main thrust of my doctoral work, I didn't collect that data. So I would just say that is not a prerequisite. People are also worried that they aren't doing enough novel work. And while I'd say that's important to worry about for yourself, don't let it preclude you from choosing a topic that interests you. There's many forms of novelty in, for example, just applying an old method to a new problem, seeing if these old methods, continue to work, new method to new problem, developing new methods, welding together methods, so that they now work on new problems and things like that. So I would just say, yeah, that's all. There are many ways that you can show novelty, so I wouldn't worry about that too much. Specifically, how to come up with a question. Honestly, one good way is just go and look at research pages. If you're interested in biodiversity, look at what other researchers are doing. Are they working on interesting data? Once you start, if you get a data set in hand, usually an interesting question pops up. Like, it's nearly unavoidable. And there's no way that everyone can look at every research question. And so if someone just hands you a data set, you're halfway to creatively coming up with an idea. The next steps are you try to answer a basic question and things like that. And sorry, I just noticed that I have a timer that we'll need to be going pretty soon. But yeah, I think that maybe we could save that for another conversation. But the fact is, once you start answering one question, even just saying like, oh, I only have 50% of the data that I need, or it's missing for this one feature, and I have all this data for these other features. If you do things like that and try to fill in the gaps, there's another technical question. And so I think there's something to be discussed, and I'd like to talk about this more in the future. There's something definitely to be discussed about how to identify a good research question. And I'd like to do an explicit video on that, because there are many components, like even just looking at where your data is collected from and things like that, that you can find out what makes a really good research project. So yeah, actually, maybe it would be good. Maybe that'd be a good one-on-one conversation. Or if you'd like, I just pop in the comments. I can do that as another live stream where I write down my thoughts and I can help you out. And then the last bit that this person said was, most of my experience comes from the customer service industry. So I'm gonna turn off my phone so it doesn't ring into the microphone. I'm having a difficult time obtaining internships, a large part of which is probably because I'm not good at interviews, nor am I, so that's fine. I thought maybe it'd be good to have my own mini research project during my free time to show companies what it takes. Is this a good approach? There's still some questions to come up with my own research. Yeah, so basically, this is a great approach. So as we discussed before, I think that this is a thing where, getting your own getting your own website and things like that, putting it up there. And just the process of making a website that people want to read is extremely useful. So I think that is useful. And honestly, the people who've done that. Oh, just one quick thing for me. What I had when I was in the job application is I literally had a folder, that a Google folder, so I could obviously turn off the link whenever I wanted. But essentially, I would just pop that to anyone who's interested in hiring me, and they could look at my publications and things like that. And I also, it doesn't hurt, when you have a YouTube channel. And the first 2 videos that I made are the ones with me showing my own work in those areas, so people can understand. Cool. And other than that, I think it looks like we have come to the end of questions. So unless there's someone's just saying hello. Hello. But yeah, if no one else has any other questions, thanks so much. Consider looking at other videos on the channel. If you, I have one specifically for early career data scientists. So there's actually a list there saying it's a video list for early career data scientists. Some of those might not be as interesting as others, or they might be for something that's already come and gone. But I'd strongly suggest you look at those. If you don't mind leaving a like, a comment in those things, any of that activity, it's not for my ego. It's to tell the algorithm to upvote this so it shows it to more people. And so the more participation there is, the better. Daniel. Thanks, Glenn. Thank you. Oh, Daniel, did you post a question like way at the beginning? Because I think that there was a, I think that some of the initial questions that people posted before it started got cut off. So Daniel, did you have a question, or am I imagining it? Because I think that you might have been one of the people who very graciously posted a comment before we started, just so that I knew everything was working. But yeah. Anyway. So yeah, we'll log off now, and perhaps if people can just give me feedback in the comment section on, for example, how you would like to hear about more of these Q&As, the topics on those Q&As. We'll have guests on future Q&As once I've worked out the technical bits and things like that. Just good ways to keep people informed about what we're doing. We're trying to make this as friendly as possible to have useful conversations, and the more you learn about this, the better. Cool. Daniel, I was asking about your perspective on data science. I'll catch you next time. Cool. Yeah. Yeah. Or if you just wanted to pop it right now, there's about a 10-second delay. But yeah. Was that? Oh, I think that was a question about data science versus statistics and how those two topics have diverged. That's actually a really interesting question. I wouldn't mind giving that the. So it's an interesting question. I would actually like to give that like a dedicated discussion. One, because obviously people are pretty feisty on both sides of that issue. And I think that it's overly popular to, for example, consider data scientists to be these like yahoos, data yahoos, just going out and not understanding things, and you don't need math to do data science and things like that. And of course, it's typical many times to consider statisticians to be people who are like too stodgy and working in the 20th century and things like that. So I don't think those are fair. I think that there are important differences, particularly derived from the industries that are using these particular skill sets. So for example, in biostatistics, that sort of scientific and experimental focus is something that you can't underestimate its importance. And so it's more of a matter of priorities. And if you look at some of my other conversations and interviews, I use the term priorities a lot because that sort of determines how people's time go and things like that. So I would say it's very similar skill sets, and you can sort of say one fits into the other, or say whatever you want. But the main thing is it's a matter of what's being prioritized by the person paying you to do the job. And so that definitely, it warrants some extra dissection and some extra consideration. But yeah, it would be great to go through and have that as a more be both broader and go deeper into those differences, because they have diverged, and I don't think it's helpful just to pretend that they haven't. But with that, everyone, thanks so much for your time. I am going to log off now. And thank you all again for your time. I do appreciate it and your attention, and have a great weekend.